Hello everyone, welcome to our channel Coders Arcade. In today's section, we will be learning about a new topic which is Introduction to Functions in C Programming. Before starting the video, I would like to request you people to please like our videos and share it with your friends and family. And also subscribe to our channel Coders Arcade so that you receive notifications about our latest updates and you do not miss out on our future uploads. Thank you. So let's get started. As I said, today's topic is Introduction to Functions in C Programming. What are actually functions? Let us see the definition of a function. A function is actually a group of statements that performs a specific task. In other words, you can also say that a function is a set of statements that takes input, performs some computation and produces the output. Functions in C programming can be categorized into two types. They are the built-in functions or the library functions, and the second type is the user-defined functions. Let us first see the built-in functions or the library functions. So the built-in functions or the library functions are provided by the C compiler itself, and they perform standard and predefined tasks. For example, we have the print function or the printf, the scan function or the scanf to read input from the user, and we also have other functions like power, square root, etc. These are called the built-in functions or library functions because they are inbuilt in the C compiler and they are designed to perform standard and predefined tasks. Now let us move on to the user-defined functions. So what are user-defined functions? As the name suggests, user-defined functions are written by the user. C language allows users or programmers like us to create our own functions. These functions can be defined by us or the users or programmers in order to perform specific tasks according to our own requirements. Therefore, these functions are called user-defined functions because we have the control over them and we can define and make them work according to our own requirements. The characteristics of user-defined functions are these functions are written by the user and these functions help to perform customized tasks. Now, C programs can be written in two different ways. The two ways are, the first one is unstructured programming, or you can say that in unstructured programming, we do not use user-defined functions. And the second type is structured programming, where we make the use of user-defined functions. All the programs that we have learned till now, we have been using the unstructured mode of programming, where what happens is the entire program is written within the single function, which is also known as the main function. From now on, we will be using structured programming and we will be writing our own functions. So these functions will be the user-defined functions and these come under the structured programming category. Now let me give you an example of unstructured programming where we do not use user-defined functions. So here is an example. You can see this program is for the subtraction of two numbers. As you can see, all the logic of the program is written within the main function, and here we have taken two variables a and b, and then we have calculated the difference, and finally we are printing the difference. So when we run this program and execute it, we get the output as follows. The output will be difference is 10. Now this is an example of unstructured programming without user-defined functions. Let us move on to the next type, which is structured programming, where user-defined functions are actually used. So here in the screen you can see this is the example of a structured programming. In this you can see the difference. The main function comes afterwards, but before that we have to declare the user-defined function. As you can see here, the name of the function is diff and it takes two variables a and b. This can be called the parameters. We will come into these things in our later sections, but for now you just need to remember that in case of user-defined functions, we have to follow it step by step. As you can see here, first we have to declare the function, then we have to define the function, and then in the main function we are calling the user-defined function. So there are three parts: function declaration, function definition, and the function call. This is also a program for the subtraction of two numbers, and when we execute this, we get the output as follows. So when we run it, we get the output. The difference is 10. So these were the two examples of unstructured programming and structured programming where we use user-defined or we don't use user-defined functions. I hope you have understood the difference between structured and unstructured programming. Okay then, see you in our next video. Thank you. In today's section, we will be learning about a new topic, which is the elements of user-defined functions. Before starting the video, I would like to request you people to please like and share our videos if you like them, and also subscribe to our channel Coders Arcade and press the bell icon so that you receive notifications regarding our latest updates and you do not miss out on our future video uploads. Thank you. So let's get started. As I said, today's topic is elements of user-defined functions. So in the previous section, I have already told you about functions, structured programming, unstructured programming. In this section, let us start with the elements of user-defined functions. How to declare the function, how to define the function, and how to call the function. So let us start with all the elements of the user-defined functions. So the first element of user-defined functions is the function declaration. The second element is the function definition. And the third element is the function call. Let us look at them one by one. The first one is function declaration, or it is also known as function prototype. It means that the function actually needs to be declared before calling that function. Without the function declaration, we cannot call the function. So the function declaration part, it actually consists of four parts. The four parts are return type, function name, parameter list with the data types, and finally the terminating semicolon. Let us look at the syntax of the function declaration. The syntax is return type, then followed by the function name, and inside the parenthesis we have the parameter list with the data type, and finally followed by the semicolon. For example, int subtract, in the parenthesis we have the parameters int a comma int b. It can be more or it can be less also. Now let us move on to the second element, which is the function definition. Function definition is the actual code for the function with the help of which we can perform the specific task. So what is the need of the function definition? Let us look at that. The need of the function definition is that it provides the actual body of the function. Without the function definition, the function won't work. So we have to provide the definition of the function. It is actually the body of the function. It contains the entire logic. The second one is it contains executable code. That means it has certain executable statements with the help of which we can define the function or how to perform that specific task. So here in the function definition, the first line is called the function header. The next very important point to remember here is that the function header should be identical to function prototype, but it should be without any semicolon. So you have to remember this point. The next point or the final point in function definition is arguments or parameters, the names that are provided to them have to be specified here with its data type in the function definition. So this was about the function definition. Now let us see a simple example so that I can explain more about the function definition with the syntax and example. So the syntax is, as I told earlier, return type followed by the function name, and then inside the parenthesis we will have the parameter list with data type, and inside the curly braces we will be having the local variable declaration, and then we will be having the statements like statement 1, statement 2, and it will go on till n number of statements. And finally we will have the return statement, because the function will return a value, right? That's why we will have the return statement, so that we can return the task or the value or the work that it is performing to our other functions, or maybe the calling function. So as you know the syntax, let us move on to one example. So as you can see in the screen, int diff, and then in the parenthesis we will have, let's say, two variables, so that I can do the subtraction between the two. So int of a and int of b. These are of the integer data type. So these are the parameter lists, including the data type. The data type here is int. And inside the curly braces, I have int diff, then diff is equal to a minus b, and then finally we will be returning the difference. So return difference, diff. The variable name can be anything, as I already told you. It depends on the wish of every user. It will vary from person to person. So this is an example of how to define a function. Simple example we have taken so that I can show you the subtraction of two variables a and b. Now let us once again recall all the parts of the function definition. So as you can see in the screen, this is int difference, and inside the parenthesis we have int a comma int b, and then int diff. So diff here is the local declaration. So we are declaring a variable which is of the integer data type in order to store the difference of the two variables. So now let us write the exact logic or the formula for the difference. So diff is equal to a minus b, and you should always remember that every statement should end with a semicolon, and finally we will return the difference or the value. So return diff. You can provide a parenthesis or you may not provide a parenthesis, it's up to you, but you have to end it with a semicolon. So now this diff equal to a minus b will be the statement. There can be n number of statements depending on our requirement, and this return diff is the return statement. And as you can see inside the int diff parenthesis, these are the parameter list, and these are also known as the formal parameters, which are a and b. Now the diff which has been written here is actually the name of the function, that's why it is function name, and the int here is actually as the type returned by this function. The return type in our case is integer. It can be float or any other. It can be character also. So this is all about the parts in function definition. I hope you understood. Now let us move on to the third element, which is function call. So only by defining a function is not enough to perform the task. In order to use the function, it needs to be called. So that's why function call is necessary. A function can be called by specifying its function name followed by a list of parameters enclosed in parentheses and separated by commas, as I showed in the earlier section. So you have to write the name of the function followed by parentheses. In this way you can call the function. The syntax is function name in the bracket parameter list. For example, diff a comma b followed by the semicolon. So this is how you can call a function difference or diff, which we have defined earlier. So this is a function call. Diff is the function name and a and b are the parameters. So in the earlier sections, you have already seen some examples using functions. So I just wanted to give you a summary of the elements of user-defined functions. So what did we learned today, we learned about the three elements of user-defined functions. Those were function declaration, function definition, and the function call. So I hope you have understood. Thanks for watching. See you in our next video. Happy learning. In this section, we will be learning more about functions and about unstructured programming and structured programming, their differences, and the advantages of using structured programming over unstructured programming. And also, we will be looking at some examples of how to write programs using unstructured and structured programming. Before starting the video, I would like to request you people to please like our videos and share it with your friends and family, and also subscribe to our channel Codus Arcade so that you receive notifications about our latest updates, and also you do not miss out on our future uploads. Thank you. So let's get started. So as I told in my earlier section, C programs can be written in two ways. The two ways are unstructured programming, or you can say which do not use user-defined functions, or the second one is structured programming, which can be said they use user-defined functions. All the programs that we have been writing till now, we have been using the unstructured mode of programming, where the entire logic of the program is written within one function, which is called the main function, as I told you earlier. So from now on, we will be using the structured mode of programming because it has various advantages over the unstructured mode of programming. So, as I told in the earlier section, here are the examples for unstructured programming and structured programming. Let us look at those once again. So, as you can see on the screen, this is the example for unstructured programming where we had a program for subtraction of two numbers, and you can see here inside the main function only we wrote the entire logic. So we had two variables a and b of the integer data type, then we calculated the difference and then printed the result. Then finally when we execute this, we get the output as the difference is 10. Now this was the unstructured programming mode. Let us see the example of the structured programming mode. In the structured programming mode, the example was like this. As you can see on the screen here, first we have to declare the user-defined function. Then we have to define the user-defined function, and finally in the main function we are giving the function call as is displayed in the example. In this case also, when we run this, we get the output, which is the difference is 10. Now, as you have seen the two examples, let us move on to the next section, which is the disadvantages of unstructured programming. So let us discuss all the disadvantages of unstructured programming one by one. The first disadvantage is, in unstructured programming, the program is very difficult to read and understand. The second disadvantage is, it is very difficult to debug and identify errors in case of unstructured programming. The next one is, programmers find it very difficult to test the program. The fourth one is, in case of unstructured programming, it is very difficult to modify the program. And the final disadvantage of using unstructured programming is that it is very difficult to reuse the logic in case of the unstructured programming. So as you can see here, we have so many disadvantages of using the unstructured mode of programming. That's why we should always try to use the structured mode of programming. Now let us move on to the next section where we will be looking at the advantages of using the structured programming or the user-defined functions. The first advantage is, when we use the user-defined functions, programming becomes very easy. The second one is, with the help of user-defined functions, the large and complex tasks can be broken down into smaller, simple tasks using several functions. The third one is, the debugging process becomes very easy and it is very easy to find and remove errors. The fourth advantage of using user-defined functions is that the readability of the program is increased to a greater extent. Then the most important advantage of using structured programming or user-defined functions is that it increases the reusability. It means that once the function body or definition has been written, the function can be called from many different places in a program and it can be used multiple number of times. So this is the best advantage of using user-defined functions or structured programming. In this case, it increases the reusability. We can reuse the logic of the code again and again. Now that you know the advantages of using user-defined functions and also the disadvantages of using unstructured programming, let us move on to our editor so that I can show you two examples where we will use unstructured programming as well as structured programming with the help of user-defined functions. So let's quickly move on to our editor. So here you can see I am inside my editor, and let's start with an example of unstructured programming. So I will start with my header file. Then here, as I am using the unstructured mode of programming, what I will do is I will use my main function void main, and inside my main function I will write the entire logic of the program. So let me take the variables. Int a is equal to 20, comma b is equal to 10, and the third variable to be difference, so that I can store the result of the subtraction in this variable. Now let me define the difference variable is equal to a minus b. Now this is a simple example, so I will just be printing the result or the difference. The difference is %d, so that I can read the variable, and here I will call my difference variable with the semicolon. So this is as simple as that. This thing is done. So I will be running this so that I can show you the output. So here I am running it, and you can see, let me zoom it, the difference is 10. So this is a basic example of unstructured mode of programming. Now let us write the same program using structured mode of programming. So let me delete this lines of code, and again I will start in this case with the user defined function. So I will take the return type, which is the int, and then I will write the name of the user defined function followed by brackets, and inside this I have to give the parameters, say int a comma int b, and inside the curly brackets or inside this function I have to define the logic. So let me take the variable to be diff, and then here I will calculate diff equal to a minus b, and finally I will return the diff value. So this is the logic of this program, and here you can see, let me just comment this out so that you can understand. This is the function declaration, and here this can be called the function definition, and after that here I will have my main function. So void main, and inside curly braces, inside the main function, I will be taking my variables. Int a is equal to 20, then b is equal to 10, so that I get a positive result. And then finally I will be taking the difference variable. And here I will use my difference variable, and from here I will call my user defined function so that I can get the result. So to call this, I have to use the name of my user defined function, which is difference, and inside the parenthesis I have to give the variables. So it will be a comma b. Now I will simply print the result. So print the difference is %d and my diff variable, semicolon. So it's done, and here this line is actually the function call. So let me just write it down here so that you can understand better. So this is the function call. Now let me run this so that I can show you the same output. I am running it. So here you can see we are getting the exact output, but with a different mode of programming. This is structured programming with the help of user defined functions. The answer is, the difference is 10. So I hope you guys have understood both the methods of writing unstructured as well as structured programming by using user defined functions or by not using user defined functions. So this is all about this video, guys. Thanks for watching. If you have any doubts, you can ask them in the comment section. I will be glad to clarify all your doubts. In the next section, we will be learning about elements of function and how to define functions, the syntax of functions and all these things. This was just an example to show you the different approach of structured and unstructured programming. Thank you for watching. See you guys in our next video. In this section, we are going to learn about a very important topic in C language, which is recursion. Before starting the video, I would like to request you people to please like and share our videos with your friends and family, and at the same time, subscribe to our channel Codus Arcade and press the bell icon if you like our videos. Thank you. So let's get started. Today's topic is recursion. So let us move on to the definition of recursion. Recursion means a function calling itself is called a recursive function or recursion. In simple words, calling a function from the definition of the same function is called recursion or a recursive function. For example, we have the main function. Then inside the main function, I will use the first print statement where I will write start. Now I want to call the main function explicitly. For the first time, the main function is called by the operating system or the OS. Second time, I will be calling it. So you can see here, inside the main function, after the first print statement, where I've written start, I'm calling my main function explicitly. Next, I'm going to add one more statement. So after the main function call, again I'm going to write my third statement, which is print end. So this is a basic example. Here you can see that we have two print statements which print the messages start and end. And in between we have explicitly called the main function. Now let's see how it gets executed. In general, to execute functions in the application inside the RAM, a memory will be allocated. This memory is called the stack memory. I am not Talking only about C language, in any programming language, stack memory is common and any function or any block of code is always executed inside the stack memory. In order to execute a method or a block of code, some amount of memory will be allocated inside the stack memory. This particular amount of memory is called frame. So for the first time, when we are executing this program, operating system invokes the main method. So some memory will be allocated to this main method. Here, one main frame will be created and a certain amount of memory will be allocated in order to execute all the three statements defined inside the main method. First, it will print the start message. In the second statement, we are calling the main method explicitly. Therefore, in order to execute this main method, one more frame will be created. Now, inside this main frame, all the three statements should be executed. So let's start again. The first statement is print start. Again, in the second statement, the main method is called explicitly. So another main frame will be created. Similarly, here also the same process will continue. It will print start. Again, we are calling the main method explicitly. So again, one more main frame will be created. If you observe carefully, every time this program is moving in the forward direction only. Once all the three statements have been executed, then the frame will be deleted and the memory will be assigned or allocated to some other method execution. But in this case, or in this example, every time the control is moving in the forward direction only. So there is no chance for the control to come back and complete the execution of the previous frame. Therefore, there will come a time when the memory will be full and the program execution will encounter an error called the runtime error, and it will be showing out of memory. So our program will terminate abnormally because there is not enough memory in the stack to continue and to complete this program execution process. Therefore, the most important thing that we should keep in mind while working with recursions is that we should be careful while writing the logic of the program, because the order in which the control is going forward, it should similarly come back and end the process where the execution process started. Therefore, we should follow that format while writing the logic of the programs for recursions. The best example to explain recursive functions is factorial of a number using recursion. Let us go to the editor so that I can show you how to write a C program to calculate factorial of a given number using recursion. After the execution, we will come back and see how the program execution occurs. So let's quickly move on to our editor. As you can see here, I am inside my editor screen, which is code blocks. So let me start by including the header file. And here I will take my main function of the integer data type. And inside the main function, I will start by writing the logic. So first I will take a variable n for the count, and then I will take another variable to store the result. Now I will use the print statement so that I can ask the user the value of n. Then I will use the scanf function to read the input from the user. So it will be %d address of the variable n. So this thing is done. Here I will take the result variable and I will call the factorial method, which I have to define outside of the main function. Factorial of n. So this is also done. After that, we will be printing the result. The factorial of %d is %d, comma, then for the first %d it will be the variable n, and for the second %d it will be the results variable. So this is also done, and just because it is and just because this function is returning integer values, I have to give return
0. So now this thing is done. Now let us go on to the function definition. So here it will be the same thing, integer data type. Then it will be factorial as I have written here. As you can see here, factorial. So it should match factorial, and then I have to take the variable which is integer and it int n. The variable can be same no matter what, it doesn't clash. It's upon your wish, no problem. So now let us go on to the definition of the function. So here it will be int result, and now the first condition is, in factorials we know that the factorial of 0 is 1. So we will use the if statement, n equal 0, then the result will be is equal to 1. Now we will go on to the else block. If the value of n is not equal to 0, then we will start the else block. So inside the else block, we will use the actual formula for the factorial of a number. So the formula is result is equal to n into factorial n minus 1. And after that, the final thing that we have to do is we have to return the result. So with this, the logic of the program is complete. Now, the question is that why is this called a recursive function? As I told, the definition of recursion is that a function calling itself is called a recursion or a recursive function. Therefore, as you can see here, inside the function definition of factorial, I am again calling my factorial method. So inside the same definition of factorial, I am calling my factorial function or method. Therefore, this is called a recursion. So I hope you have understood this. Now let us look at the execution process, how this factorial will actually execute itself. Let's see that. So now let's see how the method spaces are created, how the control will go in a forward direction, and how it will again come back. So first, the memory will be allocated to mainframe. So the starting frame will be the mainframe. We are declaring the n value and we are declaring one more variable result, and then we are reading the value of n. In the next step, we are calling the factorial method. Suppose let us take the value of n to be equal to 4. So it will be factorial of 4. The result will not be assigned. First, factorial of 4 method has to get completed and executed. So method space will be allocated to factorial of n value 4. Then the factorial method execution will start. First, if n equal 0 or 4 equal 0, as you can see, condition is false. So the if block will not execute, control goes to the else block. In the else block, n into factorial of n minus 1 executes. So 4 into factorial of n minus 1, that is 3. Now to multiply this expression, first we have to know the value of factorial 3. So one new method space will be created for factorial n equal to 3. Here if 3 equal 0, and we see that the condition is false, so in this case also if block will not execute. Control goes to the else block. In the else block, it is 3 into factorial of n minus 1, that is 2. Again, we should find what is the value of factorial 2. So one new method space will be created for factorial n equal to 2. Now if 2 equal 0, here also the condition is false. So the if block will not execute. Control goes to the else block. In the else block, it is 2 into factorial of 1. Again, we have to find what is the value of factorial 1. So one new method space will be created for factorial n equal to 1. Now, if 1 equal 0, here also the condition is false. So if block will not execute, control goes to the else block. In the else block, it is 1 into factorial of 0. Now one last method space will be created for factorial n equal to 0. Now you have to observe carefully. If 0 equals 0, here the condition is true. Now else block will not execute. In all the previous method spaces, we have seen that the else block was executed and the if block was terminated. But in this case, if block will execute and the else block will be terminated. So in the if block, result equal to 1. That means in the result variable, the value 1 will be stored. After the if else statement, what is the next statement? Here we are returning the result. So return 1, which is the value of result. The value of result here is 1. So the value 1 will return back here, as you can see on the screen, because the factorial 0 function started executing from this position. So result of the factorial 0 function will return back to the same place. So 1 into 1, therefore result equal to 1. So again this result will return back here. So 2 into 1, and now result equal to 2. So again this result value will return back here, as you can see on the screen. So now 3 into 2, that is result is equal to 6. So again this result will return back here. So 4 into 6. Now the result value is equal to 24, as you can see here. So this result will be finally stored into main method result variable. So result equal to 24. And now we are printing this result, which is 24. This value 24 is actually the factorial of 4. So this is the end of the program execution. Now let us move on to our editor again so that I can show you the output of the program that we wrote earlier. So here, as you can see, I am inside my editor again. So this was the program that we wrote earlier. Now let me run it so that I can show you the output. I'm running it. And let me just zoom it for you. So here, let me take the value which we saw earlier. Let me take 4 and press enter. And you can see the factorial of 4 is 24. So we are getting the correct output. So let me press any key. So guys, this is the entire logic of the recursion topic, which is a very conceptual topic in functions. And the best example to learn about recursions is factorial. There are many more examples, but this is the best example with the help of which you can learn about recursions. So that's why I took this example to find out the factorial of a given number. I hope you like the video. If you have any doubts, you can post them in the comment section. I will be very happy to clarify those doubts. Thank you and happy learning. See you guys in the next video. Thank you.
The topic is printing the Fibonacci series using the C language program syntax. We will be looking at the easiest way of printing the Fibonacci series. Before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Coders Arcade and press the bell icon so that you receive notifications regarding our latest updates and you do not miss out on our future uploads. Thank you. So let's get started. So let us know more about the Fibonacci series. What is the Fibonacci series actually? The term Fibonacci comes from the name of an Italian mathematician named Leonardo of Pisa, who was also known as Fibonacci. He was the one who introduced Fibonacci series to the world. Let's understand what is Fibonacci series. In the Fibonacci series, the next term is obtained by adding the previous two terms. For example, let us start the Fibonacci series. The first term is 0. The second term is 1. Now, for the third term, if we add these subsequent values, then 0 plus 1 is equal to 1. So this will become the third value. Again, for the fourth term, we add the second and the third term. So 1 plus 1 is equal to 2. Similarly, for the fifth term, we add the third and the fourth term. That is 1 plus 2 is equal to 3. Again, for the sixth term, 2 plus 3 is equal to 5. Therefore, the series will go on like this: 0, 1, 1, 2, 3, 5, 8, 13 and so on. Now let's see how we can write the C program to implement the logic and print the Fibonacci series. Generally, the question or the scenario is like this: write a C program to print first n elements in the Fibonacci series. So let's quickly go to the editor so that I can show you how to write the C program and then explain the execution. Now as you can see, I am inside my editor. So let's start by including the header file. Then I will start with the main function, and inside the main function let me declare or initialize my variables. So int data type. So for the number of elements, I will be taking the variable to be n, and then I will take 3 more variables. The first one will be a, where I will initialize the value to be 0, and then the second one will be b, which will be the next term, which is 1. Then I will also take another temporary variable so that I can store the other values or the corresponding values. So let it be c. And finally, I have to take one loop variable I so that I can iterate while using the for loop. So now I will use the print statement, and here I will ask the user to enter the value of n or the limit. So in order to read the input from the user, I will use the scanf %d address of n so that I can store it in my variable n. Now let me print the series statement. So here I will be using this, the Fibonacci series for %d elements is /n, and then here for the %d I have to call my variable n. And now let me write the logic of the program. So for that I will be using the for loop, and here I will use the loop variable which I have already declared, which is I. So it will start from the initial value, which is 1, and it will go on till the value of n or the element value which is provided by the user. So in that case, I less than equal to n. So I did not give a semicolon, let me provide it. And now I will use the increment I plus plus. So inside the for loop, our first task is to print the value of a, which is 0. So I will use the print statement, and then I will simply print %d /n, and then I will print my variable a. So as you can see here, the value of a is 0. So it will automatically print the first value in the output to be 0. So after the semicolon, now let me show you how the output will look like. So first the value of a will be printed. We can see that the initial value of a is 0. So in the output, a will be printed, which is 0. Now the first operation that is performed is the values of a and b are added, and the result is stored in C. So after printing 0, what we need to do is the value of b has to be stored in a, and then the value of c has to be stored in b. So for that, what I will do is I will write a is equal to b, and then I will write b is equal to c. But before that, I told you one thing: the values of a and b have to be added, and the result has to be stored in C again and again. So what I will do is I will write C is equal to a plus b. So this process will go on, and therefore we have this for loop. So let me now tell you the logic behind this so that you can understand. So you can see in the screen that a equal to 0 and b equal to 1. So C will be equal to a plus b, which is 0 plus 1 is equal to 1. So output is 0 for the first time, and then the updated values have to be assigned to A and B. So now A will become 1 and B will also become 1. Now in the next iteration, A plus B will be is equal to 2. Therefore, the value of C will be 2. And in the output, we will be getting the A value because only the A value has been printed. So in the next term in the output, the value of A will be 1. Again, we have to update the values of A and B. Therefore, A will be 1 now and B will be 2. Therefore, again 1 plus 2. And you can see the value of C becomes 3 now. And in the output, this value of A will be there. So the third element is 1. 0, 1, then 1. Now again the values of A and B will be updated, which will be 2 and 3. Then 2 plus 3 is equal to 5. So C will be 5 now. Now again the values of A and B will be updated. A will be 3 and B will be 5. And then in the output we will be getting the next element, which will be 2. And then the values of A and B will be again updated. You can see here the value of A will be 3 and the value of B will be 5. And then the value of C will be A plus B, which is 3 plus 5 equal to 8. Then this 3 value of A will be printed in the output. So this is the next element 3. And then it will go on, and again we will have A plus B, which is A equal to 5 and B equal to 8. And then we will get C equal to 13. So just because we have taken the value of n equal to 5, so in this case our output is complete and we will be getting the Fibonacci series as 0, 1, 1, 2 and 3. If we have more numbers, then depending on the same logic, it will go on and print the other numbers. So let us now check whether this program is working or not. For that, let me run it for you so that I can show you the output. So I'm running it. So here you can see, let me zoom it for you. It's asking me for the value of an order limit. Let me give it to be 5 and press enter. So you can see the Fibonacci series for 5 elements is 0, 1, 1, 2 and 3. So our program is working perfectly and it is giving us the correct output. So this is the entire logic of the Fibonacci series. I hope you have understood. So this is the entire program of how to implement the Fibonacci series. I hope you have understood properly how to implement it. If you have any doubts regarding this, you can post them in the comment section. I will definitely try to clear those doubts. Thank you for watching the video. See you in our next section. Have a nice day and happy learning.
Hello everyone, welcome to our channel Coders Arcade. In today's video, we will be talking about arrays in C. Before starting with today's topic, let me request you to please share and like our videos with your friends and family, and also subscribe to our channel Coders Arcade so that you get notifications about our latest updates. So let's get started. So far, we have used only the fundamental data types, namely character, int, float, double, and variations of int and double. Although these data types are very useful, they are constrained by the fact that a variable of these types can store only one value at a given time. Therefore, they can be used only to handle limited amounts of data. In many applications, however, we need to handle a large volume of data in terms of reading, processing, and printing. To process such large amounts of data, we need a powerful data type that would facilitate efficient storing, accessing, and manipulation of data items. C language supports a derived data type known as array that can be used for such applications. So what is an array? An array is a fixed size, sequenced collection of elements of the same data type. It is simply a grouping of like type data. In simplest form, an array can be used to represent a list of numbers or a list of names. Some examples where the concept of an array can be used are as follows.
List of temperatures recorded every hour in a day or a month or a year. List of employees in an organization. List of products and their cost sold by a store. Test scores of a class of students. List of customers and their telephone numbers. Or else table of daily rainfall data and so on. Since an array provides a convenient structure for representing data, it is classified as one of the data structures in C. There are many other data structures like lists, queues, and trees. We will also be discussing about this in our next upcoming videos. So we will be mainly talking about arrays in this video. So there are many types of arrays. We can use arrays to represent not only simple lists of values but also tables of data in 2, 3 or more dimensions. In this and the upcoming videos, we will be discussing how to use it to create and apply the following types of arrays, which are one-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. So let us first talk about one-dimensional arrays. Okay, let me give you an example. Suppose I want to add 3 numbers. Let me think about 3 variables. In my mind, I might be thinking of A, B, and C as the 3 variables. And what did you think about? You might also have thought about A, B, and C, right? Or else we can think about X, Y, and Z. Now the question is, why are we only thinking about A, B, C, or X, Y, Z? The reason behind this is A, B, C, or X, Y, Z follows a certain pattern, and it is very easy to remember this kind of patterns. So, whenever we think of variables in a pattern, then it is very easy to remember those patterns because it continues in a serial number or a pattern. Suppose A, B, C, D, E, or you can say W, X, Y, Z, etc. It becomes very easy to remember. Now, if I ask you to add, suppose 100 numbers, in that case, it will be very difficult to think of 100 variables at the same time because it will be very time consuming and it will fill the program with clutters and it will be very messy, right? So what we can do is, in this kind of situations, we can use arrays. So let me show you how an array looks like. An array can be represented like this. It will have the data type, then we will write the variable name followed by square brackets, and then we can give the number of elements. And you can either assign the length of the array at the beginning or you can leave it blank. It can be of 2 types. Now the question is, if I assign the length of the array, then it will be something like this. This will have 10 number of elements as you can see in the figure. Now the question arises how we can access the elements in this array. For that, we have the idea or process of indexing. The indexing in C programming starts from 0. As you can see, the first element will have the index 0 and followed by it will go on till the last number. So if we are having 10 elements, then the last number will have the index 9. 10 minus 1 is equal to 9 because it is starting from 0. So if we want to access the first element, we can write A of 0. And if we want to access the last element, we can use A of 9. So this is how you can access the elements in an array. Now let us move on to the editor so that we can understand more about this one-dimensional array. I am going to my editor now. So as I told you, I will write my main function and followed by this curly braces. Here I will assign the array, and in this program I will show you how to calculate the average of 10 numbers. For that I will be using a one-dimensional array which is also like a list. So this is the syntax of writing an array. Int A of, you have to give curly braces, and inside it I will assign the length of the array, which is 10. Then I will give the column. Now, as I told you, to access the first item in the array, you can do it by using the indexing like a of 0. So like this, you can access all the items in the array. Now you can assign values to the elements of the array like this. If I say a of 0 equal to 56, in this way I can assign values to the elements of the array. And if I say a of 9 is equal to 90, in this way I am assigning a value 90 to the last element of the array or the 10th element of the array. So for the time being, let me take an input from the user for all the elements. For that, what I have to do is I will use the printf function, and here I will write enter the 10 elements one by one. And now I will give a escape character /n so that I get the output in the next line. And please remember, you have to give the semicolon here. Now the question is, how do I take the input from the user? For that, I will be using a for loop. For I equal to 0, but the question is that I have to now assign this variable. Otherwise, I will be encountering an error. So for that, I am taking the I variable. So now I have 10 elements. So I can do it in two ways. I equal to 0. I less than 10 I can write, or else I can write I less than equal to 9. Both are correct. So I am using the first one, I less than 10. Then semicolon, I plus plus. And now I will be taking the input from the user. For that, I will use the scanf function. And here I will take the quotes and I will write %d, comma, and this is the ampersand. This is for the address. And here I will write a of I. So in this way, the elements entered by the user will be stored in the variable a, which is an array, one by one. Now I have to give the semicolon. So in this way, I will be getting all the elements input from the user and will be storing them in the array a. Now, first of all, to find the average, I have to calculate the sum of all the numbers or the elements in the array. For that, I am taking one more variable, which is sum. So for this, I have to take another for loop. Here also, just because there are 10 elements, I will be using the same logic. I equal to 0, I less than 10, I plus plus, and here I will be using this logic, sum equal to sum plus a of I. So in this way, all the elements will be added one by one because of this for loop. It will start from the first element and it will keep on calculating till it goes on to the last element. But for that, initially I have to initiate the sum value to 0, which I will be doing now. As you can see here, I have done it to 0. Now I have to calculate the average. For that, let me take another data type, which is float, and I will take the average variable and semicolon. And after this ending of the for loop, I will take average equal to sum divided by 10.0. Why have I taken 10.0? Because when we divide integer by integer, we will be getting an integer value. I want it to satisfy for float also. That's why I am taking 10.0. I have taken 10.0 because I have 10 number of elements, and the formula for average is sum of the number of elements divided by the number of elements. So now I will print the average by using the printf function, and here, just because my data type is float, I have to use %f. So I will write the average is %f, and then I will give a comma and call my average variable. So now it's done. So this is the total code. Now let me run it for you so that I can show you the output. I'm running it. You can see there is an error. Okay, I have to give a semicolon here. I have given a comma. Sorry for that. Now let me run it once again. And here also I have to give one semicolon. You people need to remember that you have to give semicolon everywhere. So let me run it again. And yes, it's asking me to provide the elements one by one. Let me zoom it for you. And I'm giving the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and say 10, and press enter. You can see it's calculating the average, which is 5.5000. So I press enter, and this is how you can calculate the average using an array. This is a one-dimensional array. In my next videos, I will be talking about two-dimensional arrays and multi-dimensional arrays as well. So here I want to tell you one more thing. You have to remember the syntax. As you can see here, array is represented by the variable name and followed by the length of the array. And if you don't assign this length, then you can put as many numbers as you want. But if you assign this length, then you have to provide 10 elements or less than 10 elements. If you provide 10 elements, then it's okay. If you provide less than 10 elements, suppose if you're providing 2 elements, then first 2 elements will be the elements provided by you, and the other 8 elements will be by default 0. And if you provide more than 10 elements, then you will encounter errors. So this you have to keep in mind. So this is how you can work with arrays.
In today's video, I will be talking about arrays in C programming. In my earlier video, I have already discussed about arrays. So in that video, I told you about one-dimensional arrays. In this video, I will be talking about the remaining topics. So before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Codus Arcade and press the bell icon so that you get notifications about our latest updates. Thank you. So let's get started. As I told you, my today's topic will be arrays in C programming, as you can see here. So I told you there are three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional, or it can be multi-dimensional arrays. In our earlier video, we talked about one-dimensional arrays. So today we will be talking about two-dimensional arrays. So what are two-dimensional arrays? Two-dimensional arrays are used to represent tables or matrices. So let me give you an example so that you can understand better. Here in the figure, you can see this is a matrix. It has rows and columns. There are particularly 2 rows and 4 columns here. And in this type of array also, we have the method of indexing, with the help of which we can refer to a certain row and column.
So as you can see here, the columns will have the indexing like this: 0, 1, 2 and 3. And at the same time, the rows will also have the indexing like 0 and 1. Because there are 4 columns, therefore indexing will start from 0 and end at 3. And because there are 2 rows, the indexing will start at 0 and end at 1. Suppose we want to represent the marks of 2 students. So in that case, we can do it in this fashion, as you can see here. So 10, 20, 30 and 40 are the marks of student 1, and 50, 60, 70 and 80 may be the marks of another student, which is student 2. So let us move on to the editor so that I can show you how to write a program on representing this matrix or table with the help of two-dimensional arrays in C programming. So now I'm moving to my editor, and here you can see I will start with the main function, and then I'll press enter and give the curly braces. So here starts our main function. Now I will take the array variable name, let it be marks. Here you have to follow this syntax. You can see here I am using 2 square brackets, and inside that I will give the row number and the column number, as I showed you in the example. So this is how you can do it. Now I will press the equal sign, and now I have to give the elements inside this array. So here I have to give one more curly braces so that I can provide the elements. So here you can see I will be giving the numbers as 10, 20, 30, 40. So this finishes my first row. Now I will write the second row. Say 50, 60, 70, 80. So now I'm done with the assigning of the elements. Now to print these elements, I need 2 for loops. So for that I have to initiate 2 loop variables. Let it be I and j. I'm giving one comma. Here I will give I, comma, j. So these are my loop variables. Then finally I have to give my semicolon. So now I am ready with my assigning of variables. Now to represent this, as I told, I have to use 2 for loops, which is also known as the nested for loop. So I'm writing the syntax for I equal to 0, semicolon, I less than 2, this is for the number of rows, semicolon, I plus plus, small I plus plus. Then here I am opening the curly brackets so that it becomes easy to understand. And inside it, I will take another for loop, and here I will take j equal to 0. This is for the number of columns, and semicolon, j less than 4, because it will start from 0 and go on till 3, 0, 1, 2, 3. So there are 4 columns. And then I will give the semicolon, then j plus plus. And here inside this for loop, I will again try to print the array now. So for that I will use the printf function, and here I will write %d, comma, then I will write marks, and here you should notice that I'm writing I and then here j. So in this way I will be able to represent the marks. So here I have to give the semicolon to end it, and as soon as I have written the first line, I want to give the control to the next line. So for that, what I will do is I will take one more printf statement, and here I will give an escape sequence, which is flash in. So this will give the control to the next line. And now with the help of this, I can print the two-dimensional array. So let's run my program and see whether it is correct or not. I'm running it. So now you can see on running it, I'm getting the output, but there is no space in between the elements. For that, what I can do is, I can give one space here so that I get a proper output. Now let me run it once again. And now you can see there is a space between the marks of the two students, 10, 20, 30, 40, 50, 60, 70 and 18. So this is how you can do it. So this is a basic example of two-dimensional array. You can see here, this is the syntax. This is the data type, this is the variable name, and this, just because it is two-dimensional, I am writing two square brackets, and inside it I am giving the row and the column values. So this is how it is done.
In today's video, we will be learning about how to perform linear search in C programming. So before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Codus Arcade and press the bell icon so that you receive notifications about our latest updates. Thank you. So let's get started. As I told, our today's topic is performing linear search in C programming. So let's start. Let us take 5 elements in an array. So, if we take 5 elements in an array, the array size will be 5. So, this gives us our first variable, which is n. So, here in this case, I am taking the size to be 5. So, n is equal to 5. Now, let us take the 5 elements. So, let me take the elements as 12, 15, 16, 17, and 3. So, these elements will take up the index like this: a of 0, a of 1, a of 2, a of 3, and a of 4. Since the indexing starts from 0 and there are 5 elements, it will start from 0 and it will end at 4. So a of 0 will be 12 and the last element will be a of 4, which is 3. Now, how to do the linear search? For that, we have to take a number. So let us search the number 17 in our case. So for that, we have to take the next variable, which is key. And as I said, we are searching the number 17. The value of key here will be 17. And let us take another variable flag, which will be initialized to 0. And as soon as we find our number, the flag value will be changed or updated to 1. But if we don't find the value of flag, it will be 0 itself. So the key value will be compared to all the elements in the array. First of all, key will be compared with a of 0, then a of 1, then a of 2. And as you can see here, the key is 17 and it is equal to the element a of 3 in our case, as you can see in the array. Now, as soon as we find the key and it is matched with the element in the array, what will happen is we will have to update the value of flag to 1. Then we have to get out of the loop. For that, in C programming, we have the break statement. With the help of the break statement, we will come out of the loop. And then we will compare the value stored in the flag variable. If the value of flag is 0, then we will say that the number that we were searching was not found and the search was unsuccessful. But if the value of flag is 1, then we can say that the
number which we were searching in our array has been found, and we will print the search has been successful. So that is it, guys. This is the logic behind the program. Let us move on to the editor so that I can show you how to write the program and execute it. So now I will be moving on to the editor. So let's get started here. As I am in my editor, first I will write a comment. Search, and I will close the comment box, and then I will start with the header files. stdio.h and conio.h. After that, I will start with my main function. And inside the main function, I will start with initializing the variables. Here, first of all, I will take the array, which is a of, let the size be 10. Then I will take the size of the array, which is the variable n. And then I will take the variable key, as I mentioned. Then I will take the flag, and I will initialize it to 0. And finally, I will take the loop variable to iterate over the loop, which will be I. Then I will give the semicolon, and I will now write the print statement. Here I will tell the user to enter the array limit or size. Then I will use the /n so that I can take the output in the next line. Then I will use the scanf function so that I can take the input from the user. I will use the %d to take the integer value from the user, and then I will store it in the variable n. And after this, I will again use the printf statement so that I can take all the elements in the array one by one. So for that, I will use the print statement, and I will tell enter %d so that I can read the n value elements one by one. And after this, I will again use the /n so that I can print the input given by the user in the next line. And after this, I will give the n variable. So with the help of this, now I will use a for loop, and here I will take the loop variable I equal to 0. Then I will take the condition I less than n, which will be less than the size of the array, because it starts from 0. Then it can go on till 4, and we will be getting the number of elements. I have to give a semicolon here and here also. Then I will increment the value of I. Here I will take a curly braces, and here inside the curly braces I will use the scanf function so that I can read the input from the user. I will write %d comma and a of I, so that I can store the numbers provided by the user in the array. So after that, again I will use the printf statement so that I can ask the user which number he or she wants to search. So here I will write enter the number to be searched, and again I will use the /n so that I can go on to the next line, and here I will use the scanf function. Then I will write %d this value will be stored in the key variable. Then here now comes the logic of the program. Here I will use the for loop, and the condition will be the same. I is equal to 0, I less than n, I plus plus. Now I will use the if statement, and here I will check if a of I equal the key value, then inside the braces I will write, as I said, flag value will be updated to 1, and then as soon as we have found the number we will break out of this loop. And finally, after I come out of this for loop, here now I will check the value of flag. If the value of flag is 1, then I will print it is successful, or else if it is not 1, then I will print it is not successful. So we can do it in this manner. If inside brackets we will write flag, that means if the value of flag is 1, then inside the braces I will print number found, search is successful. Then I will give the control to the next line by using the /n, and here I will use the semicolon, and after this I will go out of this if and I will use the else for the other condition. Here inside brackets I will print the opposite, which is number not found search is unsuccessful. Or you can say search failed, whatever you want, that doesn't matter, full stop. And here also I will give the control to the next line so that it looks good. And here I have to give the semicolon, and now we are done. So this is the entire logic of the program, and now let me show you by running it. I will run it for you now. So here let me zoom it for you, and it says enter the array limit or size. Let me take it as 5, and as I wrote in the program, here it says enter 5 elements one by one. Now I will take the elements, say 12, 36, 6, 17, and say 8, and now it will ask for the number to be searched. Here let me take as 17 and press enter, and now you can see it says number found search is successful. So that means we have been able to find this number 17 which is present in this array. Now let me show you another example where I will search for a number which is not present in the array. So I'll press any key and then I will run it again by pressing the shortcut F9, and here let me zoom it for you, and here I will give the enter the array limit or size to be again 5 say, and here I will give the elements to be 1, 2, 3, 6 and say 9. And now let me search for a number which is not present in the array. Let it be say 4, and let me press enter, and here you can see it says number not found, search is unsuccessful. So this is how we perform linear search with the help of C programming. So this is the entire program, as you can see here. As I told you, first we take the array, then the array size, and then we initialize the key value to the number to be searched, and then we initialize the flag value to 0, and this is the loop variable. Then we iterate over the loop, and if we find that the number is found, then we update the value of flag to 1, and then we print number found, and if it is not 1, then we update by saying number not found, search is unsuccessful. So this is the entire logic. I hope you understood. In today's video, we will be talking about the topic binary search in C programming. So before getting started, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Codus Arcade so that you receive notifications regarding our latest updates. Thank you. So let's get started. So as I told you, our today's topic is binary search in C programming. So for that, let us take an array. So inside the array, let us take the elements one by one. Let me take 10 elements. So the elements are 3, 5, 7, 9, 13, 17, 33, 47, 88 and 95. So before starting this search, I want to mention one very important thing, which is binary search can be performed only in a sorted array. So as you can see in the screen, this is a sorted array. All the elements are arranged in an ascending order. So here you can see that the indexing starts from 0 and goes on till 9. So here the array size is 10. And let us consider the key value to be 17, which will be the element that we will be searching by performing binary search. So we are supposed to find this key value 17 in this given array. Now the question arises, how will we perform this? So let me tell you the solution. We will first divide this array by finding the mid value or mid term. The formula to find the mid value is mid equal to start plus end divided by 2. So as you can see in the diagram, the start value is 0 and the end value is 9. So the mid value formula will be 0 plus 9 divided by 2, and it will be 9 by 2, which can be approximately termed as 4. So now we can say that 17 or the key value is greater than A of mid. That means 17 is greater than A of 4. And in the array we can see that 17 is greater than the A of 4 element, which is 13. So now what we will do is we will change the formula for start, which will be start is equal to mid plus 1. That is, the mid value was 4, so it will be 4 plus 1 is equal to 5. And we already have the end value, which was 9. So end equal to 9. We are skipping the first 5 elements because the key value 17 is not present there, as you can see. So now again let us find the mid value in this new array. Mid is equal to start plus end divided by 2. So our new start is 5 and the end value is 9. It will be 5 plus 9 divided by 2 is equal to 14 divided by 2, which is 7. Now let us check once again. 17 is less than a of mid, or 17 is less than a of 7, or we can say 17 is less than 47, which is true. So now, because it is less than the mid value, what we will do is we will change the formula for end. End equal to mid minus 1. That is 7 minus 1 is equal to 6. So we have start equal to 5 and end equal to 6. And this is our new array. So we are skipping this end part because key value is not present here, or it is less than this part. So now again mid is equal to start plus end divided by 2 is equal to 5 plus 6 divided by 2 is equal to 5 approximately. So now let us check once again. 17 is equal to a of mid. 17 is equal to a of 5, or we can see here that 17 is equal to 17. This means that our search has been successful, so we can print it. If we don't find the element, in that case we will print search is unsuccessful. So now this is the entire logic of performing binary search to find an element in an array. And as I told you, binary search can only be performed in a sorted array. So the array has to be sorted first, and then we can do the binary search. In my case, I will be taking a already sorted array, and in the next topic I will show you how to sort arrays with the help of bubble sort and other sorting algorithms. So now let us go on to the editor so that I can show you the program to implement binary search. So here I am going to my editor, and let me start by the header file #include stdio.h, which is the standard input output library. And then I will start with the int main, and inside my main function I will declare my variables which are of the integer data type. So I will take the loop variable I, then I will take the start variable, then I will take the end variable, then I will take the mid variable, then the array size n, then I will take the key to be searched, and finally I will take the array, say of 100 size, so that I can sort it for more numbers. And now I will use the printf function, and here I will ask the user to enter the number of elements, and to take the control to the next line I will use the /n. And now using the scanf function I will take the input from the user and store it by using the %d and n. So now I have taken the number of elements from the user. Now I will use the printf statement or function to tell the user to enter the elements one by one. So I will use enter %d integers one by one, and then here also I will use the /n so that I can give the control to the next line, and after the comma I will give the n value. So now again I have to use a for loop here so that I can take the input from the user. I equal to 0, I less than n, I plus plus. Inside the curly braces I will use the scanf function, and here I will take the input from the user and store it by using %d. A of I. So this is the way how I can store the input from the user, and after that I will go out of this for loop, and again I will use the print function, and here I will type enter the value to be searched, and here also I will use the /n character, and here I will take the user input by scanf %d, and I will store it in the key variable. So first I have to initialize the values for start and end. So I will take start to be 0, and because the indexing starts from 0, so I have to take end equal to n minus 1, and now I have to write the formula for mid, which is mid equal to start plus end divided by 2, and you have to be very sure about this bracket, because otherwise it will give errors or you will not be able to implement it correctly. After that I will be using a while loop, and the condition will be while start is always less than equal to end, then here I will write the condition if A of mid is less than my key value, then inside the curly braces, as I told you in the explanation, my start value will be start equal to mid plus 1. So this is the condition, and I have to take another condition, which is else if I find the key, then I have to write A of mid equal the key value, then here I will print %d found at location %d. I will tell you what I am trying to do, and let me give a full stop, and after that let me again use a escape character which is /n, so that I can go on to the next line, and after the comma I will use key and then my mid plus 1, because if I have found the key, then I will say key is found at the mid plus 1 location. And after this, if I have already found the key, then I have to go out of the loop, for which I will be using the break statement. And now, if this condition is also not satisfied, if I have not found the key, then what I have to do is I have to again compare the other condition, which is the last one, which is else, and inside the brackets I have to write end equal to mid minus 1. So this is done, and finally I have to again update the value of mid, which is mid equal to start plus end divided by 2. Now comes the condition where I will not be finding the key. Then this will be a unsuccessful search, and for that also I have to use the print function. So it will be like if start greater than end, then inside curly braces I will use the print function, and here I will type not found, and then I will use %d isn't present in the list, full stop, and then I will use the /n, and after the comma here I will take the key variable. So this is done, and because I have taken int main, as you can see here, I will use the return 0 statement at last. So this is the entire logic, and now I will show you by running it. So let me run it for you. So it says there is an error. Okay, the error is I have only written print, so it should be printf. Now it's correct. So let me run it so that I can show you the output. So here I'm running it for you. Okay, so it's asking me for the number of elements. Let me take 5, and here I will take the 5 integers 1, 2, 3, 4, 5, and now it's asking me to find the value. Let the value be, say, 5. So it is in the array, as you can see. This is the last one. So when I press enter now, it says 5 found at location 5. So this is working all right. Now let me show you for the unsuccessful search, where I will not be giving the element which is present in the existing array. So here, let me run it once again, and let me take suppose 6 elements, and 1, 2, 3, 4, 5, 6, and you have to keep in mind that you are always giving sorted array only, otherwise it will not work. And if I press enter now, and it's asking me for the value to find, let me take 9 and press enter. So here you can see, let me zoom it for you, it says not found, 9 isn't present in the list. So this is the logic behind this, guys. So here is the entire program. I hope you have understood. This is how we can perform binary search in C programming.
In this video, we will learn about sorting algorithms in arrays in C programming. We will be sorting the array elements, and for that we will be using the selection sort algorithm. Before starting the video, I would like to request you people to please like and share our videos with your friends and family, and subscribe to our channel Coders Arcade so that you receive notifications about our latest updates. Thank you. So let's get started. First of all, we will try to understand about the logic associated with selection sort, how to use it in our program, and then we will write a practical program and understand its execution. So let's start. Let us look at an example. Consider an array of 5 elements. The elements are 5, 3, 8, 2, 1. Then their index numbers will be 0, 1, 2, 3 and 4. In selection sort, one by one indexes are selected and the smallest among all the elements is placed or shifted to that particular index. In this way, the index number goes on increasing till the last index, and finally we get our sorted array. In this example, we can see that we have 5 elements and their indexing is from 0 to 4. At index 0, the element is 5, so it will be selected and then the smallest element in the array will be chosen. As we can see, the smallest element in this array is 1. Now, these two elements will be swapped and 5 will go to 1's place and 1 will go to 5's place. Now, we will have a new array. At index 0, we have 1, then 3, 8, 2, and at index 4, we will have 5. Now, the index will change from 0 to 1 and we have 3 at index 1. Again, the smallest element will be selected and interchanged with the number or the element 3. Here, 2 is the smallest element, so 2 and 3 will interchange their positions. Now, the new array will look somewhat like this: 1, 2, 8, 3 and 5. Now, the index number 2 will be selected and here we have the number 8. Again, the smallest number will be selected, which is 3 in this case, and the numbers will interchange positions. Now, the new array will look like this: 1, 2, 3, 8 and 5. Similarly, after the next pass or iteration, the array will look like this: 1, 2, 3, 5 and 8. So finally, we have our sorted list. This is the basic principle on how selection sort works. One by one, the indexes are selected and the smallest among all the elements is placed or shifted to that particular index. In this way, the index number goes on increasing till the last index and finally we get our sorted array. Now let's look at one more logic here. In the array, the index numbers are from 0 to 4, and in the selection sort algorithm, it's selecting till index 3. So it is selecting the index which is 1 less than the highest index. It's because on selection of the second last index, we already have the sorted array. So you need to remember this step because it will help you in the implementation of the for loop in writing the C program. Now let us go to our IDE so that we can implement this example on selection sort by writing a C program. So as you can see here, I am inside my editor So I will start by including the header file. Then I will start with my main function. Here I will start declaring my variables. First I will take the loop variables I and j. Then I will take the size of the array to be size. Then I will take a temp variable for swapping. Then I will take one more variable index so that I can store the index in that. And then I will take one variable, the minimum one. And finally I will take my array of size, say 10. Now I will use the print statement so that I can take input from the user. So I will ask the user to enter the size of the array. Here I will use the scanf function so that I can read the size from the user. Now I will use another printf function so that I can tell the user to enter the elements one by one according to the size. So I will use printf, and here I will type enter %d elements one by one, and I will be giving the /n escape character so that it goes to the next line. And here I will use a for loop so that I can take input from the user of all the elements in the array. For I equal to 0, I less than size, I plus plus, and here I'll use the scanf function to read the user input. %d, comma, and I will save it to the array by using the address operator. So this part is done. Now I will again use one print statement so that I can print the unsorted array. And again I will use a for loop so that I can display the unsorted array. I equal to 0, I less than size, I plus plus, and I will use the printf function so that I can print the unsorted array. %d, oh, I have to give the quote also, %d, and so that I can give a particular distance between the elements, I will use the /t, which is the tab character, and then I will use my a array by declaring it and calling it a of I. So this is done. With this we can take a input of the size from the user, and we can also print the unsorted array. Let us check it. Before that, I will just use one more thing, return 0, because this will be returning integer values. So let us run it and check if it is correct or not. I'm running it. Okay, it is asking me for the size of the array. Let the size be 5 as we saw in the example. I'll press enter. Okay, it's printing some junk values. You can see here 1733 something. Let me check what is the error. First of all, let me just close it. Okay, I can see that I have used %d, but I have not given the variable name. So here I'll give a comma and give size as the variable. So now let us check it once again. Okay, I will zoom it and let the array size be 5. Yes, now it's correct. Enter 5 elements one by one. So let us take the elements to be 5, 8, 3, 2, and finally 1, and press enter. Okay, now you can see the unsorted array is 5, 8, 3, 2, 1. So it's working till now. let us go on with the logic of the program now. So after this print statement, let us start with the logic now. So I will have to take two for loops, one to select the index and one for comparing the values of the initial index and the index after that. So for that I will be taking the for loops as for I equal to 0, I less than, and as I told during the selection shot, the index less than the highest index is selected and we get our sorted array. So it should be size minus 1. So you need to be careful about this. And after that I will give the increment I plus plus. So here this is the outer for loop. Inside that I will take my minimum value to be equal to a of I, and I will take the index to be I. Then we can go on and write the next inner for loop for j equal to 0. And here I need to tell you something, because this outer loop will actually be for the iteration of the indexes, and we need to check from the first index to the next index. So for that we have to go to the next index. How we can do it is, we have to write not j equal to 0, we have to go from j equal to I plus 1. Then our condition here will be j should be less than the size, so that we can go on till the last index. And finally it will be j plus plus. So this is how we go into the inner for loop, and here I have to use the conditional if statement where I will be checking the value of the next index with the minimum value. So for that what I will write is, if a of j is less than min or the minimum value, then inside the if statement what we will do is, if it is less than the minimum value, then we will change the value of minimum. So we can do it by writing min equal to a of j. And finally we shall also have to change the index. Here index is I, so now the index will become index is equal to j. And now we will go out of this if statement, and also we will go out of this inner for loop, and then when we have found the minimum number, we have to swap it or interchange it with the first number or the number at that particular place. So for that we need to write a statement like this. So as I have declared the temp variable already, so we will write temp is equal to a of I. Then we will write a of I is equal to a of index, so that we can change it. And finally we will be interchanging this, so it will be a of index is equal to temp. So this is the basic swapping algorithm. I hope you all understand this. So with this we have come to the end of the logic in this program, and finally what I will do is, I will go out of this outer for loop, and here I will use the print statement and I will print the sorted array. So for that I will use the slash n first, and then I will write the sorted array after selection short is again slash n, and finally for this also we have to use a for loop for I equal to 0, I less than size, I plus plus, and inside this we will be printing our sorted array. So again I will be using the printf function, and inside this I will print %d, and to give a space between the elements I will use the slash t comma, and I will call the A of I, so that I can get all the elements in my array. So with this I am done, and this is the entire program. So let me now run this so that we can see if it is working properly or not. So I will be running it. So let me zoom it for you, and here it's asking me for the size of the array. Let it be 5, and yeah, it's asking me for the elements, 5 elements one by one. So I'll give 5, 8, 3, 2, 1 and press enter. So you can see the unsorted array is 5, 8, 3, 2, 1, and after the selection sort is done, it says the sorted array after selection sort is 1, 2, 3, 5 and 8. So our program is working perfectly. So this is how you perform the selection sort algorithm. In this video, we will learn about one of the sorting algorithms in arrays in C programming. We will be sorting the array elements, and for that we will be using the bubble sort algorithm. Before starting the video, I would like to request you people to please like and share our videos and subscribe to our channel Chorus Arcade and press the bell icon so that you receive notifications about our latest updates. Thank you. So let's get started. First of all, we will try to understand about the logic associated with bubble sort, how to use it in our program, and then we will write a practical program and understand its implementation and execution. So let's get started. Let us look at an example. Consider an array of 5 elements. The elements are 13, 24, 36, 17 and 12. Then their index numbers will be 0, 1, 2, 3 and 4. We will be arranging this array in ascending order. So the final result after bubble sort will be the following array: 12, 13, 17, 24 and 36. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. This swapping is done by comparison. In this example, we can see that we have 5 elements and their indexing is from 0 to 4. In the first iteration, at index 0, the first element is 13. So it will be compared to the next element, which is 24, and then the greater element between the two will go towards the right if necessary. But we can see that 13 is smaller than 24. Therefore, no swapping will happen. Then 24 and 36 will be compared, and as 24 is smaller than 36, it will remain in its same place. Then 36 will be compared to 17, and since it is greater than 17, they will interchange positions. Then 36 and 12 will be compared, and since 36 is greater than 12, they will again interchange positions. Thus, after the first iteration, 36 has reached its desired position and the array will look like this: 13, 24, 17, 12 and 36. Now, in the second iteration, 13 will be compared to 24. Since 13 is less than 24, they will stay at their original positions. Now, 24 will be compared to 17. Since 24 is greater than 17, they will swap positions. Now, 24 will be compared to 12. Again, as 24 is greater than 12, they will interchange positions. Then 24 will be compared to 36, and as 24 is less than 36, both of them will remain in their original positions. So after the second iteration, the array looks like this: 13, 17, 12, 24 and 36. In the third iteration, 13 will be compared to 17. They will remain in their original positions since 13 is less than 17. Then 17 and 12 will be compared and they will interchange positions as 17 is greater than 12. Then 17 will be compared to 24 and they both will remain in their original positions because 17 is less than 24. And 24 and 36 will also remain in their same positions because of the same condition. So after third iteration, the array will look like this: 13, 12, 17, 24 and 36. In the fourth iteration, 13 will be compared with 12, and since it's greater than 12, both the elements will swap positions. In this way, after each iteration, the greatest element in the array gets bubbled up to its desired position. Therefore, this algorithm is known as the bubble sort algorithm. Thus, you can see that after the fourth iteration, we have got our sorted array, which is 12, 13, 17, 24 and 36. This is how the bubble sort algorithm works. Now let us go to our IDE so that we can implement this example on bubble sort by writing a C program. So as you can see, we are inside our IDE and let's start writing the program. I will start by including the header file, and then I will start with the main function. Here, let me start declaring the variables. First, I will declare my array. Let the array be A and the size be 10. Then I will take a variable to store the size. Let it be N. And then I will declare a variable temp so that I can swap the variables. And then I will take my loop variables. So let it be I, J, K and L. And finally the semicolon. Here, first of all, I will use a print function so that I can tell the user to enter the size of the array and the /n character so that the control goes to the next line. And I will use the scanf function now so that I can store the size of the array into a variable. So it will be %d, comma, and the variable will be n. Then again I will use the printf function so that I can tell the user to enter the elements one by one. Enter %d elements one by one, and then again the /n so that I can go to the next line. And finally, here I have to give the variable name, which is n. And here, to read the input from the user, I have to use a for loop. So for I equal to 0, I less than n, I plus plus, and inside the for loop, I will use the scanf function so that I can read the input from the user and store it into my array A. So it will be %d address operator A of I. So with this I can store the array. Then here I will print the unsorted array with the help of the printf function. So printf, the unsorted array is, here I will use 2 /n's so that I can give a considerable gap, and this quote should also be outside. And for displaying the unsorted array, I have to again use the for loop. So it will be, say, for j equal to 0, my other loop variable, j less than n, j plus plus, and inside the for loop I will use the printf function so that I can display the unsorted array. So %d, and to give a precise gap between the elements in the array, I will use the /t or the tab character. And here again I have to call my array by a of j. So with this we can take the user input for the size of the array, then we can tell the user to enter the elements one by one, and then we can display the unsorted array. Now let us try to run this program and check whether the program is working till now or not. Before that, let me use the return statement, because this function will be returning integer values. So now it's correct. Let me run it. Okay, so now let the size be 5, and yes, it's asking me for the 5 elements one by one. I will give 13, 24, 36, 17 and 12. So you can see that the unsorted array has been printed on the command prompt console. 13, 24, 36, 17 and 12. So our program is working correctly as of now. So let us go on and write the logic of the program. So first of all, let us write the swapping algorithm. So for that I will use a for loop, and I have two variables, as you can see, k and l, as you can see here. So I will take for k is equal to 0, k less than. Here I want to tell you something very important. We saw that when we have 5 elements in our array, in the fourth iteration we get our sorted array. So that means the looping or the iteration should be one number less than the highest element. So in that case it should be n minus 1. So here the value of k should be going on till k equal to 0 to k less than n minus 1, because in n minus 1 iterations we get our sorted array. So you need to remember this logic, otherwise you will be encountering errors in your program. Then I will use the increment, and inside this I will do the swapping algorithm. For that, first of all I have to use the if statement. So if a of k is greater than a of k plus 1, which will be the next element, in that case I will do the swapping. So inside the if statement, as I have declared the temp variable, what I will do is temp is equal to a of k, then a of k is equal to a of k plus 1, and finally a of k plus 1 is equal to temp. So this is a basic swapping algorithm. I hope you guys know about this, and I think I made a mistake here. So this will be a semicolon, and then with this we are done with the swapping algorithm, but this will be for the comparison of the numbers or the elements. But we also have to give a outer for loop for the number of iterations. So for this I will use another for loop, which is for l equal to 0, and as I showed you, the number of iterations will be n minus 1. So l less than n minus 1, l plus plus, and then we will start this for loop, and this brace will not be here, it will be after the end of the inner for loop. So for that, this is the inner for loop. So after this we will be using the outer for loop. So now this is done. Then finally, as we have printed the unsorted array, we will also be printing the sorted array. So for that, here I will again use the printf function, and I will type the sorted array after bubble sort is, and here, so that I can give the control to the next line, what I will do is I will use a slash n, and here also I will use 2 slash n's. So this is done, and to display the array I have to use a for loop. So for I equal to 0, I less than n, I plus plus, and here I will print %t, and to give a space between the elements I will give the slash t or the tab character, and finally I will call my variable, which is a of I. So with this we are done with the logic. So let us run the program and check whether it is working or not. So I'm running it, and okay, it's asking me for the size of the array. Let the size be 5, and let us take the earlier example only. 13, 24, 36, 17 and 12. So you can see the unsorted array is 13, 24, 36, 17 and 12, and after the bubble sort is done, it displays the sorted array after bubble sort is 12, 13, 17, 24 and 36. So this is it. Our program is working properly. So this is how you can use the bubble sort algorithm and sort an array in ascending order. I hope you guys have liked this video. Thank you.
So this is all about this video, guys. Thanks for watching. Hope you like the video, and if you like it, then tell us in the comment section below. If you have any doubts, then post them in the comment section. I will definitely try to clear those doubts. Also, like, share and subscribe to our channel Coders Arcade and press the bell icon so that you will get a notification when we post a new video. Thank you. Happy learning.